So, dear students, I welcome you all in the industrial pharmacy. Very good morning to you all. Let's go through the industrial pharmacy. So, dear student, we are onto the parenteral products, and while studying the parenteral products in our yesterday's lecture, we had gone through the injectable solutions, injectable suspensions, injectable emulsions, and the dry powders which are to be reconstituted before its use. We saw the characteristics, we saw the properties of different types of the parenterals and the method of preparation of injectable solutions, emulsions, suspensions, and dry powders. So these are the details that already we had covered, and this is the summary of our yesterday's lecture. Now let us move through the today's session. Now in this particular session, in the coming few slides, we will going through the details, and after completing all these details, you must able to understand the basic designing and layout of a parenteral production unit, the general guidelines required for the parenteral production and their structural specifications, the various facilities required for the production of sterile product and their performance, the European Union guidelines to the good manufacturing practices for manufacturing of these sterile products. So all these will be the topic of our today's discussion, and all these are related with that of the process of production of the parenteral products, their factory requirements, and all the things associated with their production. Now, in order to understand all these, our lesson plan that will move through the layout of the parenteral, the different sterile manufacturing areas, which are properly called as cleanup area, preparation area, aseptic area, quarantine area, finishing and packaging area. We will also move through the production facilities for parenteral sterile product manufacturing. What is the principle? What are the personal requirements? What are their protective measures, the premises, and the equipments? We will also go through the environmental air control in the form of the HEPA filters. HEPA filter, that is nothing but the high efficiency particulate air, HEPA, HEPA filters, which is also known as the laminar airflow, and the method by which we can go for validation of these laminar airflows. So let's move through the slides. Now, as far as the production facilities for the parenterals are concerned, we require some stringent controlled facilities, some of the specially designed plant layout that is necessary, that is needed. Now, why this is needed? This is needed in order to minimize the risk of microbial contamination, because it is the prime and utmost important thing in case of parenteral product that it should be sterile. So when it should be sterile, when it is completely free from that of the microorganism. So in order to maintain complete freedom from that of the microorganism, some strict and special environment, special facilities are needed to be provided during the production of the parenterals. So the manufacturing layout that should follow some standard guidelines as per the requirement. Now, in our last lecture, we saw that the CFR 211, isn't it? So the CFR 211 that deals with that of the all these GMP guidelines associated with the personnel, production, facilities, equipments, premises, requirements, etc., etc. So if you see the general guidelines, the manufacturing of sterile products that should be carried out in a clean areas, entry to which should be through the airlock system for personnel and or for equipment and material. See, what does it mean that the entry that should be airlock? So whatever it will be, whether it will be personal, material or equipment, once someone had entered, that means it should be locked and there should be a double door lock system. Now what this double door lock system is there, that will consist of the two different doors. Through one door we have to enter, then we will get entry into one room. Then in order to get entry into the production area, we have to open the another door. And the system of locking of these door, it should be such that when one door that will remain open, the another door that will get automatically locked. Now why this is, because if the two doors that will get remain open, then there are chances of mixing of outside air, outside environment with that of the inside, right? So in order to avoid that mixing and in order to maintain the proper environment, there is a need to have the double door lock system. Sometime there is a presence of triple layer, triple door lock system also, right? So that is what is the entry that should be restricted. The various operations of the component preparation, production preparation, and filling that should be carried out in separate areas within the clean area. Clean area, that means these are the controlled environment. Their temperature is controlled, their humidity is controlled, their particulate matter is controlled, their rate of air circulation is controlled, the cleaning or the removal of air or the uh, say the filtration of air, that is controlled, isn't it? So that is the strictly controlled environment, that is said to be the clean area. Now, as far as the process of sterilization is concerned, the product is terminally sterilized. That means once we are packing, once we are filling, after that the product is going to be sterilized. The process of sterilization that can be carried out by heat, by radiation, with the help of use of gases or with the help of use of the fumigants. As far as the heat is concerned, we can go for using either dry heat or moist heat. In case of dry heat, we can go for using the hot air oven. In case of moist heat, we can go for using the autoclaves. In case of autoclave, we have to maintain the 121 degrees Celsius temperature at 15 pound pressure for 15 minutes. The process that will be carried out all into the aseptic areas. So all these aseptic operations, you can see the aseptic operation carried out by a personnel working into the aseptic area. And the clean areas, these are required for the process of manufacture of the sterile products, and these are classified according to the required characteristic of the environment. So clean area, these are of various types. These are divided into the different grades from A to D, or from class 100 to class 1000 to class 1 lakh. Now based on these number from A to D and from 100 to 1 lakh, their degree of cleanliness that will goes on decreasing. So that means the class A area, that is of the upmost or the highly clean area. Class D, that is the area which is least clean compared to that of the class A area. Same is the case associated with the class 100 to class 1 lakh. Class 100, that is the very highly highest cleanliness maintained area, whereas as we will move from class 100 to 1000 to 10,000 to 1 lakh, the degree of cleanliness that will goes on decreasing. So here you can see the layout for the process of manufacturing in case of the parenteral products. The total area that is divided, like say the cleanup area, then there is a warehouse, then there is a preparation area, aseptic area, there is a quarantine, and there is a packaging. Now this preparation and the aseptic area, these are the highly cleaned areas. Very high degree of cleanliness need to be maintained into these areas. It does not mean that here the degree of cleanliness is not required. It is required, but compared to these and these areas, this area that will require the highest degree of cleanliness, because here actually the process of preparation and packaging that is going to be carried out. All aseptic operations, these are going to be carried out there. So again, this is the factory plant layout. As you can see that there is a quality control department and there is a production department. This is the particular area which is said to be the filling and sealing area, that is of high degree of cleanliness. So the entry that will be there for the production personnel from this side, and they will pass through the pre-entry wash into the gowning area where they can remove the outside clothing. Here they can wear the foot covers, they can wear the mask, they can wear the hood, gowns, everything. They have to remove all their outside wearings, clothings, ornaments. They should not wear the cosmetics. They should not have the clothings in such a that will go for shedding. So, and from here, once they will change all these, they will be passed through the compounding, sterilization, preparation, and the finished good area. Now, here, as I said, that this is the entry for the quality control personnel. So there is no mixing. So quality control personnel, they can access from this side. Production personnel, they can access from this side. And quality control, again, that is the separate area in case of a production plant, in case of a layout, right? So as far as the cleanup area is concerned, so this is the area that should withstand the moisture, steam, and detergent. The washing process that will be carried out in this area, it should be free from that of the dust, fibers, and the microorganisms. And this is the non-aseptic area. So that means here the complete freedom of microorganism, that may not be the ideal requirement, but it should have the cleanliness. And if it is there, like say the freedom from microorganism is there, then it's well and good. But it is not a stringent requirement in case of the cleanup area, because all these operations that are going to be carried out. Now, this is the area which is said to be the preparation area, where the strict precaution is to be taken in order to avoid the process of contamination from the outside. So the entry that should be restricted for the personnels in this particular area. The mixing preparation and the preparation is prepared for the filling in case of the preparation area. The aseptic area, again, the degree of cleanliness is very, very high. The entry of personnel, that is strictly controlled. Only the people who are going to be working into that area, who are going to be carrying out the process of filling and sealing, only they should be there. And their entry, that should be controlled. uh, the number of entries and exits, that should be limited one. Once they will go inside, that means they should carry out their work, and after completion of their shift they can come out. So in this area, the filtration and filling into the final containers and sealing, that is carried out. So all the equipments, these are equipped with the air control, like say the HEPA filters, laminar airflow, and the others. The quarantine area, this area that is said to be the finished product area. After filling, sealing, and sterilization, the product or the batch that is kept into this particular area. This is the area which is said to be the random sampling area. The product that is subjected to the process of sampling by the quality control department, and if any problem is found, then that problem is going to be addressed by the production department. So that's why this area is also called as the problem solving area. And once there is no problem, everything that is in accordance with that of the specification, then that will be released. The approval will be given for the process of the final packaging and release into the market. Finish and the packaging area. This is the particular area which is said to be the packaging area. All getting approvals from that of the quality control department. The product that will going to be packed, and they should be protected from that of the outside environment. As far as the guidelines which has been provided by the European Unions to have the good manufacturing practices, the sterile products, they will be divided into the four different grades: grade A, grade B, grade C, and the grade D. Now, what are these grade A, B, C, and D? The grade A, it is the local zone for high risk operations. That means it is the topmost area, very highly risk operations, like say the filling, stoppering, open ampules and vials, and making the aspects of the connections. All these process that will be carried out in the grade A area. Now, grade B, that is for the aseptic preparation and the filling, and this is the background environment for the grade A zone. That means after grade A, if which will come, that is the grade B. So grade C and grade D, again, these are the clean areas for carrying out the less critical stages in the manufacturing process of this sterile product. So as you can see that the grade A, that is associated with the high risky operations, and grade C and D, that is associated with the less critical operations. So that means the degree that will goes on decreasing as we will move from A to D, and as we will move from D to E, it will go on increasing. As far as the personnel are concerned, only the minimum number of personnel that are required, their entry that should be restricted, and high degree of standards of the personal hygiene that should be maintained, the cleanliness that should be maintained. The people should not have any kind of illnesses, diseases, or disorders, coughings, so some common colds like that. The personnel who are going to be entering, they should not carry anything with them, like say their outside clothing that should be removed. They should be taken the air bath, they should be taken the antiseptic bath. Their all ornaments, jewelries, wrist watches, they should be removed. And the staff processing which are in the biologicals, like say the microorganisms, so their entry that should be properly regulated, and they should follow the norms as per their working. They should not wear any kinds of the cosmetics, like say the powders and all, puffs and all, isn't it? Because that will lead to the process of shading of these ornaments, shading of these cosmetics, and that may contaminate the product. The clothing, they should be such that they should not undergo the process of shading of the fibers, so that it will contaminate with that of the product. So you can see here in this particular diagram, in this particular picture, the personnel who are going to be working into the parental, they had been shown. So they should wear the gowns, they should wear the foot covers, they should wear the mask, they should wear the goggles, they should wear the cap, they should wear the hand gloves, isn't it? So everything. Now this image, or this scenario, or this image that became very popular, because say in case of taking care of COVID patient, the physicians or the health workers, they are going to be using such kinds of protective measures, isn't it? The ultimate aim is to protect oneself, right? The premises, as far as the premises requirement is concerned, that should be far enough, that should be easy to clean. They should not have any kind of the uh, projections, right? All the exposed surfaces, that should be very smooth, they should be impervious, they should be free from that of the cracks, they should not have any broken surfaces, they should be properly maintained. The minimum number of projecting ledges should be there, shelves should be list, cupboard that should be at least, and the equipment, they should be such that they should be easy to clean and sterilize. The false ceiling, that should be sealed. The fixtures, they should be maintained in such a way that they should be easy to clean. The pipes, ducts, they should not have any kinds of the recesses, so that any or the process of cleaning, that will become very difficult. The premises, that should be properly guarded by the airlock system. The airlock should have the visual and or audio warning system. That means if something is going on inside, or if we have to communicate something with inside, or by the inside people with that of the outside. There should have proper provision of the video system, like say the video cameras and display units. At the same time, there should have the audio system, like say the mics and the speakers, so that what they want or what we want outside, we should able to communicate with them. They should able to communicate with us or with the outside personnels. A filter air that should maintain a positive pressure, because say if we open the door, the thing should not be such that the outside air that should go inside. So the process where the filling ceiling and all these clean area, they should have the positive pressure. So that means if the door is open, there should not be inflow of air inside of this area, it should be outflow. The various recommendations regarding the air supplies and the pressure differentials that need to be modified based on the requirement, based on the necessity, based on the production facility for the particular product. An indicator of pressure difference that is to be fitted near to that of the door, so which will clearly indicate the pressure difference, and that can be monitored. Then the sinks and drains that should be avoided in case of the production areas, in case of the parenterals. There is a need to have the routine sterility test that should be performed precisely, and equipments, they should be maintained in the maintained condition, and if any kind of maintenance need to be carried out, that maintenance should be done in such a way that the process that should not get disturbed, or if possible the maintenance process or the repair process that should be carried out from outside. A conveyor belt that should not pass through the partition between the grade A and the grade B clean areas. So that should, conveyor belt should not be there. And in case of other like say C and D, there we can use the conveyor belts. And a processing area of lower air cleanliness unless the belt itself is continuously sterilized. In case of less clean area like say C and D, we can use the conveyor belt, but that should be properly sterilized every time. So any kind of equipment services maintenance, if it is going on, that should be observed or that should be seen from outside, or if possible that should be done from outside itself. Equipment fittings and services should be from outside. The equipment validation and monitoring is most important. The water for injection which we are using, that should be routinely prepared and that should be stored at a degree of 70 degrees Celsius for the process of use of these water for injection in order to prepare the parenteral product. Or sometime if possible that should not be maintained at a temperature more than that of the 4 degrees centigrade. So either less than that of the 4 degree or above the 70 degree, that is the ideal requirement. Environment control is concerned, the surrounding air and the environment that can be of greatest source of contamination. So it can be minimized by using the preliminary filters and the special bacterial and the particulate filters. The air control is achieved by installing the first and then the HEPA filters. Electronic airborne particle monitoring instrument determine the number and size of the particulate matter. At the entrance, there is a need to have the blower. You might have seen that in case of malls and all, there is a blower at the entry. This is for what? This is in order to give you air? No, it is not for giving the air, but just not to allow the particulate or the dust matter inside of the mall or inside of these doors, right? So that's why the entry that should be guarded by the blowers. The air classification, as far as the air classification is concerned, it is defined as the number of particles per cubic feet of air that are larger than 0.5 micrometer in diameter. Now, based on these air particles and their numbers, there are different classes of the air system. So that is the class 100, class 1000, class 10,000. Now, as you can move, so this is the classification as per as the Federal Standard 209, that is the cleanliness classification, ISO classification, and it is based on the number of particle and the viable count of microorganism, average airflow, and the air change per hours. You can see the classification of these rooms, that is from 100 to 1000 to 10,000 to the 1 lakh. As you can see that the cleanliness classification as far as ISO is concerned, this has been given grade as 5, 6, 7 and 8. 100 to 1 lakh, as you can see the number of microorganism not more than 0.5 micrometer particles per cubic meter, its value that will goes on increasing. So in case of 100 it is 3500. So in case of 1000 it is 35,000. In case of 1 lakh it is the 35,200, and in case of the 10 10 lakh it is the in case of 1 lakh it is the 3 lakh 52,000, right? Or yes. So you can see that all these values they will goes on increasing. The viable count of microorganism again it will goes on increasing. So in case of class 100 there is a very least number of microorganism, whereas in case of this is 1000, 10,000, 1 lakh it is the 100. The average airflow velocity in case of class 100, you can see that airflow velocity, that is larger one, it is going on decreasing as we will move from 1100 to that of the 1 lakh. The air change per hour is concerned, so it is multiple time, it is between the 240 to 489, 490 or 480, or it is nearby approximately up to 500 air change per hour. That means the air that should be continuously replaced in order to maintain the high degree of cleanliness of this area. So as far as the classification from the European Union, you can see the airborne particulate classification for grade A to D. As we will move from A to D, the degree of cleanliness that will goes on increasing, and the number of particles that will goes on increasing, right? Less number of particles, that means high degree of cleanliness. The environmental control, here you can see that the laminar airflow that is going to be used, and the flow is called the laminar, that means in the form of the laminas, in the form of the one particular plane only, because the turbulent air that will upstream is changed by the filter into the straight line flow of the downstream phase, the lifter. So they will consist of the different basic element like say the blower, high efficiency air filter, and the plenum. So there are two different types of laminar airflows: horizontal laminar airflow, vertical laminar airflow. In case of horizontal laminar airflow, the air blow toward the worker, and this is to be used for the non-chemotherapeutic operations. In case of vertical flow, that is used in case of the biological safety cabinet. In case of the chemotherapy operations, the air blow from top to that of the down in order to protect the worker who are handling these microorganisms. So you can see this is the picture showing the laminar airflow. So this is the horizontal laminar airflow. The air that is flow in the form of the horizontal, the worker, they will sit at this particular site, and the air that will flows toward them. So that's why these kinds of laminar flow, these are to be used for the less critical and the less non-chemotherapeutic applications. Here there is a filter. This is the blower. The blower will suck the air. It will pass it through the HEPA filters. Then it will be here. There will be a filtered air. This is the vertical laminar airflow. The air that is going to be here. There is a pre-filter blower which will flows or which will blows the air through the HEPA filter, and it will pass from top to that of the bottom. This is the vertical type of laminar airflow. So in case of laminar airflow, there are all these specifications, pre-filters to that of the lighting. So all these are strictly necessary. Pre-filter, which will filter the 99.9% of the 5 micron particle. Final filter that will remove the 99.9997 down to the 0.3 micron. So they will have all these specifications. The airflow that is 90 feet per minute, and the noise level that is 40 to 50 decibel, vibration level less than 40 micro inches, and the lighting that should be minimum 645 lux. In order to validate these laminar airflow, there is a method which is said to be the dioctyl phthalate method. So in case of dioctyl phthalate method, what we need to do, we have to take the dioctyl phthalate liquid plasticizer that is heated to the point of vaporization. When it will get heated, it will be reconstituted into 0.3 micron form of the monodisperse aerosols. Now, these monodisperse aerosol, these will be dilated with the air until the concentration of 100 microgram per liter that will be achieved. That will be passed through the aerosol. This aerosol mixture is allowed to pass through the filter, and the qualitative and the quantitative observations that are done for the amount of the penetration using the scattering photometer. So this will measure the amount of uh, air or this dioctyl phthalate that is going to be passed through the filters. So this is the summary for the today's lecture. What we saw the concept of parenterals. We saw the advantages, disadvantages, ideal properties and sterile products, and the pre-formulation of the parenterals. Up till now, we had covered all these things, the formulation of parenteral, types of parenteral preparation, and today we saw the plant layout for the production of the sterile preparations. So with this, today we will stop at this particular point only.